So in previous lectures, we have seen how to separate oil, water, gas. Okay. So there are vertical separator, horizontal separator, spherical separator. Then we have seen there are emulsion treater where we add chemical, we add electrodes to remove water particle, we heat to change viscosity. So electrostatic treater, static treater. So electrostatic treater, what does it do? It will be unstabilizing the in electrostatic treater. We apply high voltage AC or DC, and using this one we try to separate water particle from oil. Now heater treater, basically this will be changing viscosity of oil. So because when viscosity is changing, the oil particle, whatever the water particle, whatever there in oil, so whatever will try to settle quickly, viscosity actually will be resisting particle to move from oil to water zone. But whenever you are heating, you are forcing oil to release water particle, so that water particle can settle quickly or slowly, and retention time will be lower. And another thing we have tried, okay, so now we have vertical separator, horizontal separator, two phase separator, three phase separator, we have gun barrel. Okay, so main purpose of horizontal two phase, three phase separator are there, like you separate oil, water, gas. Now you got oil will have lots of water particle sedimentation, so that one you have to separate. So in previous lectures we have seen how we are separating water particle from oil. So when oil or when water particle is getting settling down, so your BSW is going down, BS and W. Okay, BS and W normally it will be like 0.2 to 2% approximately. Okay, basically water will be there and some sediments and other thing will be there in that oil after separation. So that oil will be transported to your refineries. Now if we have higher BSW, so higher if BSW is there, then your customer will not buy, and some other issues will be there. If there is any ionic liquid, ionic salt, let's say sodium chloride or calcium chloride or magnesium chloride, that will be creating issue. So that after separation also 0.2 to 2% water BSW you got, still there will be certain amount of salt which will be hampering your separation and refining process. So in this lecture we will try to discuss how to separate that small amount of salt which is still remaining in the oil. So if salt content is more than 20 ppb, if salt content is more than 20 ppb, 20 ppb, pounds of salt, this unit is unique unit, this is called pounds of salt, in terms of sodium chloride, in terms of NaCl2, sodium chloride, NaCl, per 1000 barrel of oil, per 1000 of oil. Okay. So PTB, actually the full form will be pounds of salt per 1000 barrel. Okay, so equivalent to sodium chloride salt. Okay, now can be done before refinery. So refinery, when there will be increasing temperature, there will be certain issue if you have salt. So what happens, let's say if basically there will be sodium chloride salt, calcium chloride, or magnesium chloride. Okay. Now, at high temperature, calcium chloride will be broken, it will be hydrolyzed. Let us say 350 degree centigrade temperature you have, 35 degrees centigrade temperature, then CaCl2 plus H2O, it will create calcium hydroxide plus HCl, okay, 2HCl, and magnesium chloride plus H2O, it will create magnesium hydroxide plus 2HCl. Okay. NaCl does not hydrolyze. Okay. If you see the periodic table, NaCl, potassium chloride and sodium chloride, it will be the top. Okay. So, top based on your activity. So, chemically very much highly active sodium, then after that sodium or potassium, then calcium, magnesium, other molecules will come. So, if sodium chloride is there, it is very much active. So, breaking this bond between sodium and chlorine is very difficult. You need very high temperature, or you have to give some electrical mechanism or some other mechanism you can separate, but normally increasing temperature 350 degrees centigrade, it will not get separated. But calcium, magnesium is a lower strength than sodium chloride, they will be getting separated, they will be separating chlorine and it will create calcium hydroxide, magnesium hydroxide and acid. So, this acid will be creating problem. Acid will be reacting with metal and it will be creating metal salt. This iron is there in separated in all the mechanical equipment, basically iron will be using. All the mechanical equipment, basically iron will be used. So, iron plus HCl, it will be creating ferrous or ferric chloride. So, that will be softer than original iron. So, when the salt, iron salt chloride is softer, so it will create erosion and corrosion. Okay. When erosion is happening, so slowly it will be rupturing or it will be creating low strength system. So, that can create burst or leakage. So, it will be creating multiple issue. So, you have to remove calcium or magnesium chloride, this sort of salt, so that acid creation will be stopped. If you are not stopping acid creation, then there will be other issue. And again, magnesium chloride or calcium chloride, these salts will be getting deposited. Why? If you increase temperature, the salt will be there in water, okay, in soluble form. Now, water, if it gets vaporized because of high temperature, then the remaining part will be salt. The salt will get deposited at the bottom. It will be crystallizing, it will be deposited. So, it will be creating fouling on the surface of metal, let's say heat exchanger surface or other surfaces. It will be creating one layer that is called scaling or fouling. Okay. So, that will change your heat transfer property, or it will be blocking the flow path, okay, where fluid is flowing and slowly the deposition happening. So, because of deposition, the pipe will be blocked, okay, heat transfer characteristic will be changed, okay. Pure metal will have higher heat transfer rate, but when you have salt deposited on the metal surface, heat transfer rate will be going down. So, that will be another problem. So, you have to remove the salts, then you can use the oil for refining or fractional distillation in the refineries. Method of reducing PTB is referred to as oil dehydration. So, this method is called oil dehydration. Okay. And normally the separator, the refinery people, they will ask to reduce PTB. Okay, how much pound of salt is there, so that you have to reduce. So, around 5 to 10 PTB, okay. But if you are having very high amount of PTB, so in that case, the surface production operation, those people should be separating, then they will be transferring to your customer in refineries. Okay, refinery, they will have also desalting equipment. So, this desalting equipment can be placed in refinery or in surface separator operation, where on the surface the upstream people, they will be separating. But in many cases, upstream people will be doing this work, and next level, final level will be done by your refinery people. So, common salt specification will be 10 PTB. 10 PTB in SI unit, it will be like 0.003 kg per meter cube of oil. Okay. So, this much of allowed maximum. Desalting removable water as much as possible. So, in your heater treater or gun barrel, actually you removed water. When you are removing water, actually salt also will get removed, but still some salt concentration is higher, then again you have to put some extra water, that is called water wash or washing water. So, using water you have to dilute the salt and you have to remove the water again from oil. So, higher concentration of salt is there, you add more water. So, the water whatever you are putting into your system, that water should have lower amount of salt. Okay. So, after that lower amount of salt will be dissolving the higher amount of salt inside your separator system. Then remove the water again, so that what removed water will have higher amount of salt concentration, that one you dispose or you reuse for some other purposes. Okay. So, whatever water you are using for washing, the criteria is that it should not have any H2S component, or it should not have any ammonia component, or your ppm, parts per million salt concentration or debris concentration should be lower. Otherwise, this salt whatever you are putting in as fresh water and water for water washing or water bathing, so that water will be creating further problem. So, you have to remove all the salt, then use for your water washing and remove your salt for desalting operation. Because of very low water is required, the crude oil is pumped through the desalter at pressure above it, bubble point pressure. Okay. So, above bubble point pressure you are pumping fresh water and crude oil. Okay. So, pressure you are increasing little bit, then this fresh water and crude oil, both water will get mixed somewhere. That mixed fluid again you are giving some electrostatic treater and other treating mechanism, and you are separating the remaining salt, and you are reducing salt PTB to 10 or low. Salt will be doing some more action also. Salt will crystals will be deactivating catalyst bed, and it will be plugged downstream processing equipment in the refineries. Okay. So, in refineries there will be catalyst to convert crude oil to different component. So, that will be deactivating. So, that will be another problem. So, first you have to remove salt, means surface production operation people will be doing some part, maybe some part will be done by your refinery people, or maybe surface production operation salt removal part will be enough for your refinery application. Desalting, removal of water as much as possible. A typical horizontal electrostatic treater used for desalting operation. So, electrostatic treater along with some chemical you have to add, and heater treater also will be there. So, heater treater chemical for deactivating your emulsifying agent, heat to change your viscosity, then electrostatic separator system you use, so that small particle will get separated from the crude oil and your total salt content will be going down. So, here one example heater treater I have taken from NATCO dual frequency electrostatic treater. You can see this is Schlumberger website I have taken. So, input voltage you can see 380 to 480 voltage, output voltage 74, and the ambient temperature -4 to 131 degree Fahrenheit it can work. Okay. And this NATCO dual type electrostatic treater, it is having AC plus DC both type. I think you can remember in the previous lecture I told, like I will have one AC section, one DC section, AC, DC. So, DC section, small particle will be polarized and it will move towards electrodes. Okay. But in AC section you are giving alternative frequency. So, large amount of oil, it will be having water particle will get distorted, and it will be vibrating continuously. It will get distorted. When it is getting distorted, more possibility that they will be colliding each other, they will be making bigger particle, they will be settling at the bottom. In DC section, if you have very small particle, you apply very high voltage and particle will get ionized, those ionized particle will move towards electrode, and when they are moving towards electrode, they will be colliding more, they will be getting bigger particle, they will fall down, slowly it will be moving down, and it will come to AC section, where larger water per amount, they will get distorted, the particle will be getting distorted, and they will be colliding, and they will be creating bigger particle, they will be settling down. So, this NATCO dual frequency system will have AC DC both systems, so that small amount of water and larger amount of water in oil both will get separated. So, mixing equipment. Now, I said like water, fresh water and oil should be mixed. So, how it will be mixed? So, normally they will be using one globe valve. So, how this globe valve works? So globe valve will be like this. It will have pipe like this. Okay, then it will have pipe cross section, then it will like this. One stem will be coming, one plug, this is called plug. Okay, this is called plug. So plug will be blocking this flow path, and one stem is coming, and this is called bonnet. Okay, so bonnet will be blocking the path, and there will be one knob. Okay, from where you can turn. This is stem, and fluid will be flowing like this. Okay, so inlet, outlet, and if you rotate the knob actually, so if you rotate the knob, so knob will be closing this flow path. Okay, closing or opening, so you can control how much fluid you can pass through this globe valve. This is called globe valve. Okay, globe valve. So this will be controlling flow, and it will be helping in mixing of oil and fresh water. So how this fresh water and oil will be mixing? So normally there will be one pipe coming like this, then inlet flow will be there, then you can see this. Okay, so oil in, so oil with higher percentage of salt, percent of salt will be coming, and there will be diluting water. So this diluting water will have lower amount of salt concentration. Okay, now we are injecting through this, and this diluting water will be passing through some nozzle. Lots of nozzles will be there. Okay, so nozzles are there, so it will create spray. So you are creating spray means you are creating lots of small particle. Okay, lots of small particle of water. It will be mixed up with main oil stream, and it will go through this mixing chamber, mixing section. Okay, so when it is going through mixing section, lots of mixing will happening, lots of small particle will be created, oil and water, water will be mixed up. Okay, so this is nozzle. Okay, or injecting nozzle, Okay, so whatever water is coming here, it will be sprayed from here. So it will be your injecting water, a small particle. So it will be washing the oil which is having lots of salt. So salts will get diluted. When diluted, it will be settling down, and your total amount of salt will be going down. So this is called schematic spray nozzle system. Spray nozzle system. Okay, this is mixing section or mixing valve. Now from mixing valve, mixing section, it will go to your okay, yeah, so this valve section, actually this one. Okay, now how this mixed fluid is coming out from your globe valve, how it will be mixed into your separator. So your separator is like this. Okay, separator will be going like this, and it will be spreading inside separator. Electrode will be there. This is electrode. Okay, electrode is here, one electrode is here. Okay, and this water crude. Crude is going through this, okay, and water will be going out from here. Electrodes are there, then desalted oil. So desalted oil, it will going out from here, and maybe in some cases you can inject steam also. So you can control temperature, okay. So this is water layer. So water oil interface, this one, water oil interface, okay. So you can see this crude oil moving through this pipe, and it will be getting spreading here. When spreading here, there will be two electrode, positive and negative. Using the positive electric negative, you are separating small particle, and oil will be creating layer over here, okay. So the oil you can take out from the top section, and water heavier, so that will be creating a layer at the bottom. From bottom you take water out. So this is simplified diagram of a electrostatic treater. So these electrodes are there, so electrodes are separating, okay. This is figure simplified diagram of a electrostatic desalter, okay. So here fresh water or diluent water is inevitable actually, so that you can dilute and you can remove the water, and you are removing amount of salt, and BSW also going down. Pressure drop through the mixing valve varies from 10 to 15 psi, okay. Pressure drop through pressure drop through mixing valve is 10 to 50 psi, okay, 10 to 50 psi. Required pressure drop can decrease by installing pre-mixing device. So in that case we have pre-mixing device, like nozzle we have put, so this is reducing your pressure drop, okay. So valve will be sharing the droplet. So pre-mixing means you are mixing oil and water, but valve will be sharing the droplet, will make very small particle. But if it is too small particle, again you can remember the settlement formula Vt. So too small particle will have difficult in separation, okay. So that is also one negative. So your intention should not be to create very small particles, rather smaller particles, so that proper mixing can be possible, and fresh water or low salt concentrated water can interact with the higher concentrate of water, and they can get settled out. So properties of crude oil, if you can see, water in crude by percentage volume 0.1 to 2%, average 0.3 to 0.5%. Okay, this section I have taken from one book, Nelson Petroleum Refinery Engineering. And salt content PTB 10 to 250, okay, and average will be 60 to 130. Salt concentration 0.4 to 25. Salt in ppm, if you see 4,000 to 250,000. Average value of the PTB, some typical oil, Middle East oil 8, East Texas is higher actually, Gulf Coast, and Canada, there's heavy oil is having very much high salt content, 200 PTB, okay. In that case you may need very higher amount of temperature increase. Okay, one problem is here, okay. So find PTB of a crude oil having 10% volume of remnant water. If its concentration is estimated to be, concentration is estimated for 40,000 ppm at 25 °C. Okay. So, to find this PTB, actually there are some chart, some formula also there. So, we can use chart also. Okay. So, 0 to 20, 0, 20, 40, 60, not 0, 0, 40, 60, 80, 120. Okay. 40, 40, 80, not 80, 120, 160. Okay. Yx, this is salinity of brine, 10 power 3 into ppm, equivalent NaCl. Okay. Now, y-axis is 20, 40, 60, 80. So, this is equivalent NaCl in PTB, equivalent NaCl in PTB. So, this curve goes like this. So, 160 is just crossing, and okay, it is going like this. Now, this figure shows salt concentration of crude oil, concentration of concentration of crude oil, PTB, as a fraction of salinity of its remnant water. Remnant water 0.1% or 1 by 1000 by volume remnant water. Okay. So, PTB of crude oil having 10% remnant water with 40,000 ppm salinity is found to be 14 PTB. You can see this figure, this is 14 actually. In actual drawing in book, it is 14. Okay. So, my drawing little bit different. So, it is 14 right within that one. For crude oil containing 10% remnant water, the value PTB is coming 14. So, given crude oil is 1400 PTB, okay, because here you have to multiply by 100. So, it is coming 1400 PTB, okay. So, they have written that you have to multiply by 100. So, it will be 1400 PTB.